When I gave you a Twizzler, did you think that it was going to pertain to the lesson?
Yes.
Oh,
Yes.
I'm not tricky at all, I guess. Okay. All right. So I need you to turn to page 149. And I want to go back to our parallel Twizzlers. And I suppose we'll just talk about lines now. Boring. 149. Peyton, you're the most U.S. citizen in this room. I guess.
No way.
Yes.
Oh yeah, that's true.
Peyton, what does it mean when two lines are parallel?
Are by each other, but they do not intersect.
That is true. What else is true?
They will never touch.
Okay.
I feel like your tongue
So I want you to think back to last chapter, and we talked about parallel and perpendicular. What was true about our lines that are parallel?
They have the same slope.
Yes. They have the same slope. Okay. So really a shame about the two parallel lines. They have so much in common, but they'll never meet. Okay. So here is what you demonstrated with your Twizzlers. Okay. And I wanted to talk about this thing with the Twizzlers before I showed you this picture. So you could actually like think about it before you knew what was really going on. Okay. This is what we've been doing right here. I've been giving you two lines and you have been finding me the one coordinate where the lines intersect. However, that's not always going to be the case. If we have parallel lines, we are not going to intersect. Okay. Because they're parallel. That's the definition. So when that happens, we're going to write no solution. Okay. Now, if our Twizzlers overlapped, they shared more than 1 point. Okay. Now, the Twizzlers stopped, like Sophia pointed out, but our lines go on forever. All right. And if we have two lines that overlap with each other, well, really, that just means they're the same line. Okay. And if the lines are the same, we're going to have infinitely many solutions because they intersect at all of the points on the line. And how many points are on a line? An infinite number. Okay. So before we get into the algebra part of it, let's just kind of talk about what this would look like. So if we had one solution, we would have two lines that are not parallel and they are not the same. Okay? If I graphed these two lines, since they have different slopes, then they're not parallel and obviously not the same line. So these are going to intersect at one place. Okay? We've seen that a lot of different times. Now, if we have no solution, our lines are parallel. So for example, y equals 3x plus 7 and y equals 3x plus 1. Those two lines have the same slope. So they are never going to intersect. Okay. Okay. Now, if we have infinite solutions, then we literally have the exact same line. But here's the deal. it's probably not going to look the same. I'm not going to give you two of the exact same equation. It's going to be kind of hidden. It's going to be disguised. Okay. Now, I am not asking you to put every single one of these into slope-intercept form, y equals mx plus b, to identify slope so you can say parallel, same line, not parallel, so they intersect. No, we're going to figure it out with our algebra, but I need you to understand visually what is happening. Okay? So, we are going to go through your problems here. All right. I want you to turn the page and we're going to go straight to number 4. Now, we have a quiz on Friday and oh my gosh. That's fine. On Friday's quiz, I'm going to ask you specifically solve by graphing, solve by substitution, solve by elimination, and then I'm going to let you pick. Okay. So in a case where we would get to pick, man.
That's looking mad elimination.
Okay, do I have a pair of variables that have opposite coefficients? Okay. What happens to my x's?
They died.
Let's not say that, please. What happens to our y's? So on the left side of my equal sign, what do I have? We have Estelle. On the right side, what do we have? Okay, Abby. When does 0 equal 9?
Never. So no solution.
So since 0 will never equal 9, there is no solution. And that's the answer that I want. Okay. Now, what does this mean? Sophia, if we have 2 lines and our intersection point is no solution, what does it mean about our 2 lines? You just said it. They're parallel. Okay. These 2 lines are parallel. Strange sounds. Yeah. Okay. Let's look at number 5. Now, number 5. Would we like to do substitution or elimination? Let's see.
You're gonna have us raise our hands.
It's fine. Holden, why would elimination be a nice choice? Okay, the x's have opposite coefficients is what I'm noticing. Oh, what about the y's?
It's not parallel.
Okay, so what happens on the left side? My x's cancel, my y's cancel out. So what do we have on the left side there? Anna, what is -3 plus 3?
Yeah.
Okay, Aiden, how many times is 0 equal to 0? Always. He says always 0 is equal to 0. Do we agree?
That sounds about right.
Okay, 0 is always equal to 0. So like an infinite number of times?
Yeah. That sounds weird.
It does sound weird. Okay, since 0 is equal to 0, it happens all the time. All of the points they share, we have infinite solutions. Okay, what does this mean? We have the same line. Okay. So in these 2 special cases, your x's and y's will disappear. If you get a number that equals a number and it's the same, it might not be 0 equals 0. Especially if you use substitution, you might get like 5 equals 5. As long as you have a number equals a number and they're the same, you have infinite solutions. But if you get something like this, where you have two numbers equal because your x's and y's went away, and they're not the same number, then that's no solution. Okay. So let's see what happens with number 6. Okay. Jaya, if you looked at this problem and you got to decide personally whether to use substitution or elimination, what would you choose?
Elimination.
Jaya chose elimination. Kane, what do you think is popping out at her to make her want to use elimination? Okay, our y's are already opposite. Someone's phone is on and it's bothering me. Could you please put it on silent? Thanks. It went boop, boop, like that. Now, if we do elimination, this is pretty cool because my y's cancel out. And we have 5x equals 5.
I have no idea. Oh, yeah.
Okay, so tell me, Nirvan, is this a no solution or infinite solution kind of problem? Oh, okay. Did you hear that? I'm really sad because I think some people were talking when Nirvan answered the question and he answered it really well. What did you say? One solution.
Wow. Congrats, Yvonne.
Okay, so since we're actually getting a number for x or y, we have two lines that are intersecting in one point. Now, you don't need to write one solution. I want to know what the coordinate is. So we know that x equals 1. Peyton W, do you want to go back to the first or second equation to find y? Second one? Sounds good. We'll go here. So 3x plus 5y equals 8.
Wait, so whenever it's one solution, we have to give the coordinate too?
Yep. Because that's what we've been doing this whole time. Yep. Okay, Maddie has a great question. Do we need to write one solution when there's one solution? No, I just want to know what the coordinate is, okay? Now, there could be a situation where I ask, how many solutions does this have? That would be the case that you could tell me one solution, okay? But if I'm asking you to find me the intersection, if I ask you to solve a system of equations, I need you to actually give me the coordinate, okay? So, these are nice numbers, aren't they?
Yeah.
I know the back of your worksheet didn't have like such nice numbers. These are, right? Here's I'm sorry, let me make up for it. Okay, so 5y equals 5, so y is 1.
Oh, I got that. Yeah, me too.
Okay, now, Sophia, is there a way for us to know that this is the right answer? Yes. How do we know? Yeah, it's 2 times 1 minus 5 times 1 equal to -3. Is 3 times 1 plus 5 times 1 equal to 8.
Yeah.
Okay. Now, those problems were set up very nicely for us. Okay. I want you to just look over at 17. And without us doing any work. Oh my gosh, those fractions is going to be horrible. What did you say, Sophia?
Oh, it's parallel.
Okay, Seth, how do we know that those two lines are parallel in 17? They have the same what? They have the same slope. Now, Seth got excited because he was like, hey, we can use substitution, right?
We don't have to.
Okay, well, let's just see. Maybe you have tunnel vision and you don't notice that they have the same slope, so they're parallel. And you're excited like Seth, and you say 2/3 x plus 7 equals 2/3 x minus 5. And then we would subtract 2/3 x from each side and have 7 equals -5.
It would work for both. You could either see that right away.
Okay. Since 7 doesn't equal -5, that's how we know to say there's no solution. And Sophia, how many times do parallel lines intersect? Never. There's no solution to an intersection of parallel lines. So that's how these two are coming together. Okay. I know that I have sent you out of here with quite a bit of homework in these past few days. I'm still giving you homework, but I'm gonna go ahead and we're gonna start our homework a little bit earlier than usual in class, okay?
You really turned this there the first time.
But you know what, if you can get it done in class, then.
Yeah.
Okay, so I know for sure that 3 through 8 all is your first one. And then you have like 9 through something odd. So I'm gonna get it loaded into Google Classroom now. You can look off of up here for 3 through 8. And then Google Classroom. Manny, is it 9 through 21? It's 5.4. 9 through 21. Okay. 3 through 8, all. 9 through 21, odd.